Okay, hello everyone and welcome. Here we are for the Module 2 review. And in this chapter, or this module I should say, you're dealing with data and measurement. Let's see what we have first. Okay, first off, what is data? All right, data is collected information about a given topic. In this little diagram that I have below, you see a couple of things here. What do some of the kids spend money on these days? Well, you have food, you have school supplies, clothing, and electronics. Based on the data provided here, it looks like electronics has the overwhelming majority of the money spent. So as you can see in that little pie chart there, 60% is for electronics, 30% for clothing, 7% on food, 3% school supplies. Okay, now while that may not be exactly realistic, the graph shows those percentages. Again, data is collected information about a given topic. What is the statistical process? The statistical process is a way to collect and organize, understand, and represent data. And you may have a bunch of numbers on a page, but don't know exactly what they're talking about. They may be jumbled or scrambled, or there's just different types of bits of information. It's almost as if you have random words on a page. Your job is to put them in a way that others can understand them. If you're an author, if you just had a bunch of words on a page, it wouldn't make up much of a story until you put those words in a way that someone else can read and follow along. It's the same thing with statistics. It's the same thing with data and measurement. You're putting stuff in a way that other people reading the graph or reading the chart can fully understand what you're talking about. In this example, we have a bar graph. So bar graphs are typically used to represent data categorically, or in categories, to put it simply. All right, so if you look down below here, you have an X and Y axis. All right, the X lists the number of names of companies. The Y axis lists the amount of money. And in this case, they're talking about the 10 companies who are sprinting ahead in terms of revenue. So how much money are they making? The blue company here is in the lead with $514 billion in revenue. This company all the way to the right in yellow is almost maybe a little over 200. Okay, so bar graphs, as you've seen, represent data in categories. Maybe something simpler would be, what is your favorite ice cream? And you could poll the class, who likes chocolate, who likes vanilla, who likes cookies and cream, who likes butter pecan, something along those lines. The bar graphs are used to show data in different categories. Histograms, while they look like a bar graph, which are used in categories, histograms represent quantitative data, So in this case, there's bins or there's intervals. What you want to make sure you notice in this graph here, the intervals here. In this case, they go from 1 to 5, or they go from 6 to 10, 11 to 15, 16 to 20, 21 to 25, 26 to 30. The intervals are always consistent and not really skipping around. They're going in order. 0 to 5, 6 to 10. And you want to also notice that they're consistent in terms of the size of the interval. They're not, for example, one of them is not, 5 places. The other one is, 6 to 25. They both go up about in numbers of 5 here, okay? You have an X axis, all right, just like always. You have the Y axis, just like always. All right, so X and Y axis here, the histogram shows quantitative data. I like to remember they look like books on a shelf. If you went to the library and you saw here, you have, say this was a math book, something along those lines over here, the red one. And then this one was a science book or something along those lines. So if you opened up your locker, how would it look? Would you have those books kind of lined up in your locker there like that? Okay. So you have another book there, another book there. So anytime you do a histogram, make sure the bars are connected to each other. Well, if we go back to the previous slide, you have the bars on a bar graph are separated by a space. Okay, just keep that in mind when you graph that. You can kind of differentiate between the two. What is a box plot? You'll see those asked a number of times coming up in the chapter. What is a box plot? A box plot divides a list of data into 4 sections called quartiles. So quartiles, just like you see the word quart or quarter in a game or quarter in a dollar, means there's four sections. All right, there's 4 quarts in a gallon. Okay, so the number 4 and quart goes along together. So if you have a group of data, say for example, your teacher gives you a list of scores, and they say for extra credit, put those scores into a box plot to determine what the maximum is, the minimum is, the median, those types of things. So first of all, put the numbers in order. That's step 1. Put the numbers in order. All right. From there, you can immediately show which one's the minimum and which one's the maximum. Once you put them in order, you'll easily be able to find the median, which is the one right down the middle. Okay. After that, you want to find Q1. Q1, also known as the lower quartile, which is basically the halfway point between the minimum and the median. And on the other side, you have quarter 3 or a quart Q3, that is the upper quartile, which is the halfway point between the median and the maximum. If they ask you for this, the IQR, remember that is the interquartile range. That is from Q1 over to Q3. They're not interested in the minimum or the maximum. In some books and in some problems, they refer to this as a box and whisker plot, because you obviously have your box, right? Everybody can see the box in the middle. You have a box, and then the parts on the edges look like whiskers. If you were a cat, right? These are the whiskers hanging off the edge. So a box and whisker, or really simply a box plot. Okay. So remember, divided into 4 sections known as quartiles. Outliers. What are outliers? These are the values that are much larger or smaller than other data values. Now, math words aren't too complex. These are the numbers that lie outside, so they call them outliers. All right. So look at this chart on the left. You have all this information scattered along this dot plot here, and they're plotted here, they're plotted there, and then all of a sudden you have this one all the way out there by itself. Okay, that would be the outlier. Same thing here. You're graphing all these values of whatever the category is, whatever the problem may ask for. And then you have this one all the way out there. That is your outlier. So it's the numbers that are much larger or much smaller than the other data values. Look at the bar graph on the right, and maybe they're asking, what's the most common name in some cases or in the school, all right? So you have Amelia, Chloe, Claudia, Erica, all the way here to Jane. Most common name up here, and maybe it's about 24, where all the others, the other one closest is 8. And then all these maybe are about like 2 or 1, something along those lines. So the outlier is the number that is either much larger or much smaller than all the others. They lie outside, also known as outliers. The next part we're dealing with is the normal distribution and z-score formula. So normal distribution, all right, first of all, you have the median right down the middle. Okay, you have the median right down the middle there. All right, so coming down here is the median. You may also know this looks like a bell. This is also known as a bell-shaped curve or just a bell curve. So if you ever hear that word, they refer to a bell curve because it looks like a bell. If this was hanging from like a church or a steeple or a Christmas bell or something like that. All right, you have a bell, and it shows the normal distribution, different standard deviations. 34% from the mean, up or down, that's the first standard deviation. Another 13.5, 13.6% from there is the second standard deviation. And then the last, about 1 or 2% more on this side, and that's how it would be the third. And you see the symbol here, standard deviation, looks like a circle with a little O at the top. Right, it's a Greek letter, sigma. So maybe you see that word, SIGMA. Okay. And then the mean, it looks like a letter U. That's really the Greek letter for mu. So MU. And we use those words for mean and standard deviation. So when you want to find the z-score, you take the raw score, which is x, you subtract the mean, and then you divide by the standard deviation. So the x is the raw score. All right. The U, or it's really mu, is the mean, and the O, or sigma, is the standard deviation. Now they'll give you 2 or 3 of those, and you find the third, and then from there you can figure out the z-score. All right, they're going to give you some of this information. You can solve it algebraically to determine what the raw score is, or what the mean is, or what the standard deviation is, to determine what the z-score is. Or they'll give you the z-score, and then you have to plug in the raw score, and you have to find the mean because they already gave you the standard deviation. They're going to give you some of those values in order to solve to get the missing value. Okay. The next one here, converting units. All right, here's a little chart here going from weeks to seconds. All right, weeks, days, hours, minutes, seconds. Remember that when you convert units, you must remember the conversion rates. Now, this is just talking about time over the week. Say you wanted to figure out how many seconds are in a week. Well, you may not necessarily go right from weeks to seconds. You work down the chart here. So you're going to go from weeks to days, right? You know that there's 7 days in a week. So, times 7 gives you a number of days. Then times 24 gives you the number of hours. Then times 60 gives you the number of minutes. Then times 60 again gives you the number of seconds. And on the flip side, if you want to go from a smaller unit to a bigger unit, right? Obviously, seconds is a lot smaller than weeks. You're going to divide in that case. All right? In this case, divide by 60, then divide by 24, divide by 24, divide by 7, divide by 7. Now, keep in mind, it's not always those numbers. It's only 7, 24, 60, and 60 because we're talking about weeks, and there's 7 days in a week. Then we're talking about hours. There's 24 hours in a day. Then 60 because there's 60 minutes in an hour. And then 60 seconds every minute. Just remember that when you're converting, you want to know that the conversion rates. Another example, say you're going from pounds, I'll put it up here, pounds to ounces. Well, if I gave you 50 pounds and you wanted to know how many ounces that is, well, you would have to know that 1 pound is 16 ounces. So just like here, when we went from a bigger unit to a smaller unit, we multiplied. We're going from a bigger unit to a smaller unit. We need to multiply 50 times 16, and that would give us the number of ounces. 50 times 16 would give you how many pounds? 50 pounds and 16 ounces in a pound. That's going to give us 800 ounces. 800 ounces. On the other side, if you went from 800 ounces and you want to know how many pounds that was, just like we went from seconds to minutes, we would divide. You would do 800 divided by 16 would give you how many pounds. The last part here, we have accuracy and precision. Those are 2 words that you kind of hear, and maybe people use them interchangeably. And while they're both related, they're actually quite different. And the best way to differentiate between the two is actually look at the picture. All right, so if you look at this first target here, you're shooting arrows in archery. All right, they may be accurate. All right, they're all kind of on there, but they're not very precise because they're spread out. They're not really near each other. Okay, you're all on the target. These are all getting points, so you're pretty good. Have some pretty good accuracy, but you're not very precise because you're kind of spread out all over the target here. On target number 2, you're pretty precise because they're all grouped together. You're getting that general area, but you're not accurate because obviously you're looking for the bullseye. Okay, so you may be precise, but you're not accurate. And in the third one, here it is, you're both. You're precise because you're all around the same amount of space. You're pretty close together, and you're accurate because you're actually hitting the target where you really want the most in the bullseye there, and for the most points in this case. Okay. So go back and review Module 2. How's a brief overview of some of the things that we covered? All right. You had the data. You had the statistical process, bar graphs, histograms, box plots, uh, different values with standard deviation. You have outliers. You have converting units, and then accuracy and precision. Let us know if you have any questions. Keep in touch. Thank you.